currently studying computer engineering in UET Lahore under roll number 2022 CE10. Continuing the presentation of our software engineering course, my agenda will include examples of different types of licenses, license compatibility, which include rules for combining softwares with licenses, then patents and trade secrets, which means protecting innovation, and then types of information and understanding data categories. Let's start with examples of different types of licenses. The MIT BSD X11 expat and ISC are permissive software licenses that gives users broad rights to use, modify, merge, publish, distribute, and even sell copies of the softwares. The Apache License 2.0 is a permissive license that allows free use, modification, and distribution of software with added patent protection rights. It is popular because of its clear, safe terms, making it lawyer-friendly for business use. Added patent rights in Apache License 2.0 means that anyone who uses the software has permission to use any patents related to it, so they don't need to worry about being sued for patent issues. The GPL family consists of copyleft licenses that ensures any changes to the software must also be shared under the same open source terms. Like we can't share the modified version under any other license. Now this slide includes the comparison between different types of licenses which we viewed in the previous slide. Now this slide shows the license compatibility where we can see that MIT BSD are purely permissive. Apache 2.0 is like in between, and LGPL and GPL are restrictive and constraining. Now we have licensing contributions. It basically tells how we can contribute to open source projects that contain some licensing. Inbound is equals to outbound means that any code you contribute to an open source project automatically follows the project's license. So if the project uses a permissive license, your contribution is also shared under the same license. This rule is clear on platforms like GitHub, where each commit adopts the same project's license. A contributor license agreement is a legal document that contributors sign to confirm they have the right to contribute and agree to the project's terms. It can assign copyright to the project's main managers or stewards, giving them official ownership. The CLA may also allow the project steward to change the license or offer the code under dual licenses. Finally, the Developer Certificate of Origin or DCO is a lightweight agreement. Here contributors add a line in their commit message like signed off by to confirm they own the code and are agreeing to the license. Now to apply a license, we can first add a license file in the main folder of project. This file states how others can use, share or modify the code. Then for some projects, it is recommended to add copyright and license notice at the top of each file so users know the licensing terms for each part. Next, it is essential to track the license of dependencies. These are external libraries or code you might use. Using SPDX identifiers makes tracking easier. Finally, ensure you have documented rights for everything your project uses. This often includes a software bill of materials listing the licenses of each component. For example, Python does this to clearly show all included licenses. And this is about which license you should use in the course project. For external projects need a signed license agreement with the client, possibly transferring control. For internal projects, student can decide to publish openly or keep it as coursework without public sharing if identified. Then for resources, we have open source legal guide. You can use the links as well, which are also given in the slides. Then license selection help. This mainly tells us about the comparison between the different types of licenses, and then there is a detailed license list. Patents and trade secrets. Patents are designed to protect innovators by granting them exclusive rights over their innovations. Unlike copyright, which protects the expression of an idea, patents apply directly to the idea itself. To qualify, an invention must be non obvious, novel, and useful. For example, a patent can't be granted for something obvious, like the way you reverse a car. A real life example of patent is the use of silver wire in currency notes. Patent rights prevents others from making, using, selling, or importing the invention without permission. In contrast to patents, standardization involves creating generic solutions that are open and available for all. Getting a patent involves a formal application process where the inventor discloses the invention publicly in exchange of exclusive rights, usually lasting 20 years from the filing date. While patents can be challenged in the court, doing so is very costly and time consuming, and most disputes are settled outside the court. Because of the high burden of proof, patent protection is both powerful and complex. There are several problems that can occur due to patents. The tech industry is advancing so quickly that it is hard to pinpoint where ideas originate. Broad patents are sometimes granted for routine concepts, leading to overlapping patents that cover similar ideas. Some companies require patents for promotion, and international differences make standards inconsistent. Patent abuse is also common. There are large companies hoarding patents, which means that a company collects or holds a large number of patents to block small and sue others. Often, big companies use court challenges like Project Django by Cloudflare to invalidate abusive patents. Two well known examples of software patents are arithmetic coding and H.264. Arithmetic coding is a way to compress JPEG files, reducing file size by up to 25%, but it was covered by IBM patents until around 2010. As a result, it is rarely used in JPEG libraries online. H.264 is a popular video compression format, has over 6,000 patents managed by MPEG LA, covering encoding, decoding, and transmission. While Cisco provides a free version of H.264 for users, if someone wanted to build it from scratch, they would need to pay licensing fees. Now we have trade secrets. Companies can protect their confidential business information through trade secrets. To maintain this protection, the owner must take reasonable efforts to keep the information secret. Employees are not allowed to disclose these secrets, and competitors cannot use any secrets they acquire through unfair methods. Even if they are leaks, the trade secret status remains valid and the protection does not expire. Non disclosure agreements (NDAs) are often used to legally ensure that individuals do not share trade secrets, and it is important to read these agreements carefully before signing. Then we have export law. Export laws are regulations set by governments that control what can be sent out of the country, including software and intellectual property. In the US, two key regulations are the International Traffic in Arms Regulations (ITAR) and the Export Administration Regulations (EAR), which aim to prevent sensitive technology and information from reaching potential enemies. These laws can affect various technologies, including aerospace and cryptography, leading to security issues since some services become insecure if they only use export grade cryptography. Violating these regulations can result in severe penalties for both individuals and companies. Computer systems often manage sensitive information that people want to keep private. It's important to consider what information can be collected legally and ethically, as well as how and where to store that information securely. Companies must also be careful about who they disclose private information to, limiting access to authorized users only. Additionally, there should be clear guidelines on when private information should be destroyed. As laws and social norms regarding privacy are evolving quickly, organizations need to stay updated and adapt their practices accordingly. Types of information. There are different types of information that we can categorize. Specific facts are straightforward data points, like when person A used Google to search for keyword B. Then we have metadata, which in simple terms we say like data about a data. Such as when an email is sent from address A to address B. Aggregate information combines various non identifying facts which can sometimes lead to identifying individuals, like knowing that someone is married, lives on Highland Road, drives a red Toyota, and works for Colonel. Then we have some common privacy regulations, which include FERPA and HIPAA. FERPA protects students' educational records, ensuring that grades and enrollment information remain private. HIPAA safeguards medical information, often requiring the use of specific compliant third party services like AWS or Zoom to ensure that patient data is secure. This is all from our